Alright, so this is just a review and kind of a compilation of all the different ways we have set up these algebraic problems in Chapter 1. So 1 through 3, this is using the segment addition postulate, which just says that your total is equal to part 1, whatever your part 1 is, plus your part 2. So you just need to set up equations using that idea. So I'm going to run through the first one with you. So we want to find the length of ST. I need to solve for x first. So my total here would be RT is equal to my part 1, which I'll call RS, plus my part 2, which is ST. And then I plug in my actual equation. So RT is 32 equals RS, which is 4x, plus ST, which is 12x. From here, I have 32 equals 16x. If I divide both sides by 16, I get that x is 2. Okay, and then I'd love to be done, but this did ask for the length of ST. So now I need to plug in ST is equal to 12x. So ST is equal to 12 times 2, means ST is equal to 24. So that's how you're going to do these problems. So 2 and 3 are going to follow the same. You'll set up your total equals part 1 plus part 2. 4 and 5 are actually doing the exact same thing. I just didn't give you a picture here. So it says that point J is between H and K on your HK. We want to use this information to write an equation in terms of x and solve the equation. So what's happening here is you have this line for both of these. You have a line HK, and you have some point J that's between them. So you just have to fill in what goes where here. So you'll want to draw a picture for this one, but it's still following that segment addition postulate. 6, 7, and 8 are a little different. This is using the midpoint, which says that you should have both segments equal to each other. So this one says part 1 is equal to part 2. So instead of having a total, you do still have a total, but you might not know anything about your total. So for number 6, for example, I want to find ln, so I'm going to solve for x first by setting lm equal to mn. So I have x plus 9 equals 4x. If I subtract x from both sides, I get 9 equals 3x. If I divide by 3 on both sides, I get that x equals 3. I'd love to be done, but again, I have to plug that in. So I can plug it into ln as my total here. So I can plug it into both of those and add them up, or remember that these are equal, so I can plug it into one of them and double it. So I'm going to plug it into mn, so 4 times 3. So mn is equal to 12, which means that this segment is 12 and this segment is also 12. So in the end, I know that ln is equal to 24. So that's using the midpoint. 9 and 10 are using the midpoint formula. So as a reminder, your midpoint formula is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. So it's just filling in, so you need to name your x1, y1, x2, y2. 11, 12, 13, and 14 are the same idea. You're going to name an x1 and a y1. You're just finding the distance. So it's distance equals x1 minus x2 squared plus y1 minus y2 squared. So those are the two formulas for those two sections. 15 and 16 are your angle addition postulate. Which says that your total angle is equal to part 1 plus part 2. Sorry, running out of room here. part 1 plus part 2. So if we look at the first one together, I'm given that ABC is 94 degrees. So ABC is my total. So I can set this up as ABC is equal to my first angle, which would be ABD, plus my second angle, which would be CBD. So when I fill these values in, ABC, they told us was 94. ABD is 3x plus 15. And then CBD is x plus 7. So when I fill this in, I'm just going to combine my like terms before I rearrange here. So it's 4x plus 22. Subtract 22 from both sides. So I get that 72 equals 4x. Divide by 4 on both sides, so I get that x equals 18. Remember, it didn't just ask me for x, it asked me for CBD, which is this angle here. So I need to plug 18 in there, so I can say that the measure of angle CBD is equal to 18 plus 7, which is 25 degrees. Okay, so you're going to do the same thing for number 16. 17 and 18, again, we have this word bisects, which means it's going to be a midpoint. So you're going to set angles equal. Anytime you have the word bisect or midpoint, it's one where you just set these equal to each other. So for for number 17, I would set 4x equals 3x plus 6. So then I'm going to subtract 3x from both sides. So I have x equals 6. I'm not done. This wants us to find ABC, which again, ABC is my total angle. So I'm going to plug it into one of those. In this case, I'm going to plug it in here. So I have that angle ABD is equal to 4 times 6, which would be 24 degrees. So if I know that this one's 24 degrees, then this one's also 24 degrees. So my total, my angle ABC is equal to 48 degrees. (19) and 20 are similar to your 15 and 16. You're going to have these two parts added up. But now the only difference here is, notice one of these is complementary, one of these is supplementary. So for the complementary one, you're going to have 90 degrees equals part 1 plus part 2. For the supplementary one, you'll have 180 degrees equals part 1 plus part 2. Okay, so that's going to be 19 and 20. For 21 and 22, this is using that linear pair versus vertical angles. So linear pair, remember, adds to 180. So you're going to set it equal to 180 because it's supplementary. And then the vertical angles are equal to each other. So you have to decide which of these you're going to set equal to each other and which of these you're going to add up to 180. And just notice here this 16.5x is this big outside angle. It's not that little one inside. And then 23, 24, and 25 are what we did yesterday with chapter 1.6, where you just set them equal to each other. I will say 25 is a bit of a challenge. You guys can do it. But it's a challenge because the x squared does not cancel out, so I just want you guys to remember about square roots. Okay, so give this a shot. If you have any questions, let me know. This is going to be more time consuming. It's important that you show your work because it's a little trickier.